Welcome. The following is a presentation from Absolute Value Learning Center.
Hello. Let us look at the next problem that I had posted on our website. And this is the issue about a car being stuck in mud. So let's read the problem first. Your car is stuck in mud in front of a nearby tree. You have a steel cable which you can tie tautly to the tree and the car. You and your friend together can apply a force of only 400 newtons while it takes 1000 newtons to pull the car out of the mud. So what can you do to pull the car out? And why does it work? Right? So again, the key word here is tautly, right? It's very tight. You can tie it very tight, but you can only pull up to 400 newtons, and it takes 1000 newtons for the car to get out. So what can you do in this situation, right? So let's take a look. So if the two friends, they pull the car directly out, they can only apply a force of 400 newtons, so it won't be enough. So in order to get to 1000 newtons, they need to get the help of the tree. Okay, so how do they get the help of the tree? Instead of pulling the car directly out, with the tree behind them and the car in front of them, they should actually pull sideways on the cable, like shown here, right? So you have this cable and you pull it sideways. Now the assumption is that they won't be able to pull it a whole lot because it's taut, which is good. Yeah, the more taut it is, the better, because they'll only be able to pull it a few degrees towards themselves. And what happens when you do that? So when you do that, the cable actually pulls on the tree, okay? And the tree pulls on the cable by Newton's third law. So guess what? Now the tree is helping pull the car out, right? Because the tree is also pulling on the cable along with these two friends. So let's see how this works in theory, right? So here's a force diagram, and here is the force F that the two friends are applying on the cable. The cable is this white line which has been deviated from the straight topped picture that it was there earlier to a degrees theta. Let's just call it theta, right? A very small angle theta. So what happens for equilibrium? So since the friends are pulling on the cable, so therefore there are tension forces set up in the rope, and these tension forces are kind of unique in the sense that depending on what the object is, the directionality of the force in the cable changes. So if you think of this little point here as your object, then for this to be in equilibrium, the tension is pointing away, right? It's pointing away. So that means the cable, in effect, is pulling on this point in those directions. But what's happening at this end and at this end here on the tree side and on the car side? On the tree side, the cable is actually pulling on the tree. Okay, so remember, so the directionality has changed. The cable is pulling on the tree. In fact, the tree is then pulling on the cable, right? And so that you have to keep in mind, that the tension force in the string acts both ways depending on what the actual object is that you're looking at for equilibrium. So let's just do a quick math on this. You can resolve this tension force into T cos theta and T sin theta, right? And same with this tension force, T cos theta and T sin theta. So for equilibrium, this force here must be balanced by 2 times T sin theta, right? So now assuming that the cable is taut and the friends are not able to pull it more than, let's say, 10 degrees towards themselves, then what happens is this theta is 10 degrees, right? And if you plug that 10 degrees into F over 2 sine theta, you get 1150 newtons, right? Imagine, so a 400 Newton force becomes more than 1000 newtons. And why does that happen? Because in the denominator you have a sine theta, and theta is a very small angle. So sine of that is a very small number as well, right? Sine theta is almost close to 0 when theta is 0, close to 0. So you get a boost in T, because, the sine theta is sitting in the denominator. So, and where does that boost come from? it comes from the tree. Okay, because you're pulling on the tree and the tree is pulling back on the cable. So you're basically taking the help of the tree in pulling the car out of the mud. Got it? Thanks for watching.
We hope you enjoyed this presentation from Absolute Value Learning Center. Please follow us on Instagram at absolute.value.learning and go to our website to register for courses today. Thank you.